Hello, ADC. We are heading to develop brain-like intelligent system for autonomous intelligence. In general, intelligent systems require auto-adjust perception, cognitive, and adaptation capabilities, would need in-situ information capture and online learning during the operation. At ADC, we attempting to capture this capability in the narrow focus of image objects, from which it can provide an effective situation awareness for further application. In BIS, there are two operating building blocks which mimic the brain architecture: short-term and long-term memory. This feedback between short-term and long-term memory form as foundation as autonomous intelligent system for our approach. RAND Corporation suggests in the report on advanced autonomous system in 2019 that embedded computation and retraining are the key feature for it. Deep learning is not the right architecture and right tool for autonomous due to no online learning capability. ADC BIS is developed and equipped with the BIUL-inspired unsupervised learning we call BIUL, a short-term memory, and dynamic supervised learning we call DSL as long-term memory building blocks. BIUL is able to track the object change with adaptive feedback capability without the big memory retrieval, while DSL is online learning of what BIUL tracked and provided. In short, BIUL get object data while DSL is trained data to form an autonomous self-generated sample data and self-learning system. Autonomous intelligence is obtained. Let me talk a little bit about the application for BIS, potential application, and for the revolutionized ISL through sensor autonomy. That's application. It can be strategy. With the BIS, we can process the sensor data at the sensor level, and we use the local processing to detect and track an in-situ learning object condition of interest. We share the intelligent data for immediate and later uplink, and we combine multi-BIS units as intelligent and tactical data fusion network. So that's a strategy. What about benefit? It's intelligent. Why? Because the real-time adaptive and in-situ learning in the autonomous feedback to become smarter on the fly. And resilient, we have multiple sensor units, process data, and no risk a single point failure. Stealth, because it's local data processing. Efficient, each unit can use a low-cost swap cost system. And versatile, BIS can be customized to use at any OE and IR sensors. And now let we move to deeper level. The overall system we propose for BIS over here, and you look at is the whole architecture. The BIS stay inside, and we have a 4D building block. BIS is the central for learning, but in order to do that, first we got to provide them the single few sample data coming during the training, okay, and the raw video training. And from short-term memory, able to generate the data for long-term memory to learn. And the end of this building block, we have the full equipped knowledge brain like a system. The unique of this technology is autonomous, it's adaptive, online learning, feedback loop between short-term and long-term memory, fast, hardware-friendly, implementable approach. We're going to discuss in different presentation. It's not in here. Let me dive down to the deeper to the level, so I can give a experimental study in the real world video. As we discussed, we gave an interest transit subject, just single object, and we have a raw data containing the interesting object, and the BIUL BIUL able to extract the feature and go to the raw video data tracking the object, and adaptive loop play in here. It's autonomous real-time adaptive feedback learning. Then finally it's spelled out on the self-generated training sample of the object from the raw video data. With this data, we're going to fit into dynamic supervised learning to learn without man supervised, completely by itself, self-learning. And with this building block, finally it can to evolve and learning by itself. And the come out is we have fully equipped brain like a system. And that's we're going to give you a demo to the next slide. And as we discussed, in this building block for this bio-inspired unsupervised learning, a short-term memory will fit data in, okay, and the video data containing interest subject streaming coming, and start to do extract the information. And here's a demo. Yeah, at the beginning, we fit this initial object, and it extract and it do the feedback loop tracking. It no memory retrieval. The previous and the intermediate step, it can get involved in the feedback loop, and that's why it requires very low computation requirement and very effective. And it's in line with how our brain system tracking. And as you see, it keeps changing, but it keeps tracking the object moving, okay, based on the feature from bio-inspired supervised learning in the feedback loop. And when it's finished, it tracks on the way down, and it's able to generate the auto-training data for DSL. That's the data it's on about. This data going to fit to the dynamic supervised learning to do the learning. And with this data already send directly into dynamic supervised learning, it do some learning. And the architecture we use in dynamic supervised learning, we're going to discuss in some other video, not here. Okay, but the whole idea is it dynamic architecture is based on the data structure, and it's able to accommodate the new object coming in real time, in situ situation. And let we run it. And now, first we upload the data in here, and that you're going to see that's data going to upload into training set. Okay, and it start to do the learning. And because it costs about 5.8 minutes to learn about 7,736 sample. So that's why we go ahead, just skip it. It keep learning in the background. We're going to move ahead and go on the way into the system continue learning. Okay. And you notice it, dynamic supervised learning is a self-learning algorithm. Just provide data and do learn by itself. Okay, we're going to discuss in different video. And now after 5.8 minutes, it already learned. I say, okay, I already done with the learning. And on the error, each hidden unique comment, how it can involve. And finally, if you look at closely, and you see over here is the final energy root mean square is about 0.009. Another one is 0.005. Okay, and now you see between the feedback loop, BIUL and DSL is already done the learning. And now let's go to test it out. And now we test the knowledge. What we provide you before is we have a short-term and long-term memory already done. And the brain now fully equipped with the knowledge, what it is in there. It's just a neuron and synapse, and that's about it. And we're going to fit the data in and see how it's performed. But one thing I want to bring it up is, in this case, when we present any frame, and the fully equipped knowledge brain like a system, we can to look at every object in the frame and try to determine what is the right one. Okay, and tracking that, provide the detection recognition for that object. Okay, and let me run it. And as you see, we present every testing frame and able to track is, say, that's where is the object we just learned, okay, from short-term and long-term memory. It's not perfect at this moment, but yeah, it come over here, you see it's make a mistake here. It make a mistake. But yeah, let's run on the way down and see how it's performed. And finally, we're going to evaluate it. Yeah, you see, most of the time, it's able to do the right detection and recognition. With that, remember now is only fully equipped with the neuron and synapse, nothing else in there. Okay, and let's discuss about the result. And as I already showed you, is given a single interest object, and we use the BIUL to generate the generate training sample, and this generate training sample fit into the dynamic supervised learning to perform self-learning. And with all of this capture into the brain BIS, and we're going to test it out with 1/3 of the training and 2/3 of untraining data with the full frame resolution 560, 576, and 696 from raw video data. And we got about 88.5% correct with RAN 1. In conclusion, we demonstrated BIUL a factor serve as the generating training data from an initial semi-object as short-term memory. And DSL successful self-learning to train the data based on its own distribution. Two things we have to pay attention. Based on its own distribution and self-learning architecture as long-term memory. This is the new invented from ADC. When we have a full equipped with knowledge from feedback between short-term and long-term memory, and the BIS already formed. And BIS can serve as a cornerstone for machine intelligence. Thank you.